treating your knowledge and skills like investments.
Oh, I love that analogy.
It's so powerful, right? Just like a financial portfolio needs constant investment, diversification, so does your knowledge base.
Makes sense. You wouldn't put all your money in one stock, would you?
Exactly. So why limit yourself to just one programming language or tech stack or whatever?
Keep those options open.
Exactly. The authors even suggest learning, get this, at least one new programming language every year.
Every year.
Wow. I know, it's ambitious. Do you actually try to do that?
You know, I try to. I might not, master every single language I dabble in, but the process of learning, it exposes me to different paradigms, different ways of thinking.
Yeah.
It's like stretching those mental muscles, gaining new perspectives.
Totally. I can relate to that. I recently picked up a functional programming language, and honestly, it's totally changed the way I approach certain problems.
It's like learning a new tool for your toolbox.
It is. And it's not just about languages, right? The authors, they advocate for reading technical books, attending conferences, engaging with that wider programming community.
Staying active, staying engaged.
Exactly. It's about being an active participant in the ongoing evolution of software development.
The tech world's always changing.
Always moving, always changing. It's easy to feel like you're falling behind.
Yeah.
But by continuously learning, by expanding that knowledge portfolio, well, we can stay ahead of the curve. And it's not just about blindly absorbing information, right?
Yeah.
It's about being a critical thinker, questioning those assumptions, evaluating new information carefully.
It's easy to get caught up in the hype.
It is.
Yeah.
Especially with the amount of information out there these days. It's overwhelming.
It is.
So we need to develop a filter.
We do.
And the authors remind us to take a step back, evaluate those pros and cons, make informed decisions about what we choose to learn.
Makes sense.
And this critical thinking, it applies to communication as well. They make this bold statement: English is just another programming language.
Interesting. I like that.
It's a great way to emphasize the importance of clear, concise communication, right? It's not just about writing code. It's about expressing your ideas effectively.
Whatever you do.
Exactly. Whether it's in documentation, emails, even casual conversations. We often underestimate the importance of communication in software development. But think about it. Unclear requirements, poorly written documentation, miscommunication between team members. I mean, these things lead to major delays, costly errors.
No one wants that.
Nobody wants that. So the authors, they encourage us to apply that same level of care and precision to our written communication, as we do to our code.
Makes sense.
Know your audience, be clear and concise, and strive for accuracy and readability.
Solid advice.
And speaking of expressing ideas clearly, Chapter 7 dives into one of the most, I think, fundamental aspects of programming, naming things.
Ah, yes, naming. The struggle is real.
It sounds deceptively simple, right? But as the authors point out, choosing good names, it can make your code so much easier to understand, to maintain.
It really can. Think about it. We spend so much time reading code.
Often, more time than writing it.
Absolutely.
So clear, meaningful names, they make a world of difference.
They do. In terms of readability, comprehension, it's huge.
They really emphasize choosing names that reveal intent. So it's not just about, picking a random word. It's about choosing a name that clearly conveys the purpose, the meaning of a variable, a function, a class, whatever.
Makes sense.
It's like giving your code self-documenting superpowers.
I like that.
When you see a variable named, customer name, you instantly know what it represents. But if it's just like X or temp, you're left guessing.
You are.
And they suggest that if you're struggling to come up with a good name, it might actually be a sign.
A sign of what?
That you don't fully understand the concept, or that your design is flawed.
Oh, interesting. It makes you think.
It forces you to really think about the role of each element in your code and to clarify your design.
I see that.
And they also stress the importance of consistency, honoring those conventions of the programming language, of the community. It's about writing code that's easy for others to read and understand.
It's like speaking the same language as your fellow programmers.
Exactly. Consistent naming conventions, they make code more predictable, easier to navigate.
Absolutely.
Now, while they strongly advocate for the DRY principle, they do acknowledge there are times when pragmatism might require some compromises.
Compromises.
It's refreshing, isn't it? They don't present DRY as like an absolute dogma.
It's good to have that flexibility.
Sometimes duplication, it might be necessary
Yeah.
for performance reasons, or to work around like limitations in a library,
Right.
or, just to simplify a particularly complex piece of code.
It's a judgment call sometimes.
It is. It's about choosing the right tool for the job,
Yeah.
even if it means bending those rules a bit. The key is to be conscious of those compromises, to document them clearly, and to avoid unnecessary duplication.
Whenever possible. It's a balancing act.
It is. Finding that sweet spot between like elegant design and practical considerations.
Finding that balance.
Exactly. And this leads us to another important aspect of being pragmatic, estimating.
Estimating. Everyone's favorite guessing game.
It can be tough. I've seen projects go way over budget, behind schedule.
Yeah.
Simply because of poor estimates.
It happens all the time, unfortunately.
It's a tricky skill for sure. But the book, it offers some really helpful strategies for making more realistic estimates and avoiding those common pitfalls.
Like what?
Well, they emphasize using ranges, right? Instead of single point estimates. So instead of saying a task will take, 5 days, estimate a range, say 3 to 7 days.
Okay.
This acknowledges that inherent uncertainty allows for some wiggle room.
Sets more realistic expectations.
Yeah.
Prevents those situations where you're constantly having to explain why things are taking longer than planned.
Exactly. They also highlight the importance of understanding the units you're using. A 5-day estimate has a very different level of precision than a 5-week estimate.
Huh.
And they even provide a table that maps durations to appropriate units.
Oh, wow. That's helpful.
It's like a cheat sheet for estimating.
I like it.
And sometimes, honestly, the best way to get a realistic estimate is just ask someone who's done it before. Tapping into that experience of others, it can save you a lot of time, a lot of headaches.
It's about leveraging that collective wisdom of the team, the community. Don't be afraid to ask for help.
No, absolutely not. Now, Chapter 16, it takes us back to tools, but this time, it's not about those fancy IDEs or frameworks. It's about embracing the simplicity and the power of plain text.
Plain text again. I thought we covered that.
We did touch upon it. But this chapter, it dives deeper into, into the advantages of using plain text for a wide range of tasks beyond just writing code.
Beyond the code.
It might seem a bit counterintuitive,
Oh,
right?
well.
In today's world of visual tools and, and rich text editors. But the authors make a compelling case for the durability, the portability, the flexibility of plain text.
It's timeless in a way.
It is. It's a universal format. It can be read by virtually any computer system, regardless of the operating system or the software you're using.
Future-proof.
It is. It's future-proof in a way that other formats, well, they're just not. And because it's so simple, it's incredibly adaptable. You can easily manipulate plain text using a wide range of tools.
Yeah, that makes sense.
They advocate for using plain text not just for code, but for configuration files, for documentation, even for storing data. It simplifies version control, parsing, collaboration.
Simplifies a lot of things.
It really does. It's about choosing tools that are simple, that are reliable, and well, that stand the test of time.
Tools you can count on.
Exactly. They also talk about, about shell games and becoming a power editor.
Now we're talking.
I know, right?
Yeah.
The shell or, the command line interface, it can be incredibly powerful for automating tasks, for interacting with your operating system. It might seem intimidating at first, but once you get the hang of it, it's a huge productivity booster.
It really is.
It's about learning to use those commands to manipulate files, to process data, to even write scripts. To automate those repetitive tasks that would otherwise eat up all your time.
Those little things that add up.
They do. And they encourage us to choose a powerful text editor and to become truly fluent in its use. Learn those keyboard shortcuts, explore the advanced features, customize it to fit your workflow like a glove.
Like an extension of your hand.
Exactly. It's like treating your editor as an extension of your mind, a tool that allows you to express your ideas in code with speed and with precision.
I like that.
And speaking of precision, they delve into the art and science of debugging in Chapter 17. It's a skill that every programmer, well, needs to master.
We've all been there, staring at that bug, wondering where it came from.
Oh, yeah. Debugging can be frustrating,
Mm-hmm.
but it's also incredibly rewarding, when you finally track down that elusive bug. And the book, it offers some great strategies for approaching this challenge. Systematically.
Systematically.
They emphasize the importance of of reproducing the bug reliably so you can really understand its behavior.
Understand what's happening.
Exactly. Then use techniques like binary search to isolate the problem. Challenge your assumptions. Use debugging tools to gain that visibility into the program's execution.
Binary search for debugging. That's an interesting way to think about it.
It is, right. It's a classic divide and conquer approach. Instead of going through your code line by line, you can eliminate large chunks of code at a time until you narrow down that problem area.
I see. So it's especially useful for those large code bases, right? Where stepping through every single line would be impractical.
Exactly. And they also stress the importance of challenging your assumptions.
Challenging your assumptions. How so?
Sometimes the most frustrating bugs, they're the ones that seem impossible.
Oh, I know those.
And that's often because we're clinging to a false belief, about how the code should work. So it's about being willing to question everything, to be open to the possibility that our understanding is flawed.
So it's a humbling experience, but it's also essential for becoming a better debugger.
It is. It's about embracing those that's impossible moments as opportunities for learning and growth.
That's a good way to look at it.
And they remind us that debugging is a skill. It's a skill that can be honed with practice. The more you debug, the better you become at identifying patterns, at recognizing symptoms, at applying the right techniques.
The more you do it, the better you get.
And they also highlight the importance of using the right tools. Debuggers, loggers, profilers, all those tools that can give you deeper insight into the inner workings of your code.
It's like having a whole toolkit at your disposal.
Exactly. Now, Chapter 18 might seem a bit unexpected for a programming book. It's about text manipulation.
Text manipulation, that sounds more like something a linguist would do.
You might be surprised how important text manipulation skills are for programmers. Pragmatic programmers, they're comfortable working with text in all its forms.
In all its forms.
They can extract data from log files. They can transform code into different formats. They can even generate documentation from code. They use tools like regular expressions, scripting languages, specialized text editors to automate tasks, to gain insights from their code.
So it's like a Swiss Army knife for text.
It is. You can slice, dice, and manipulate text to fit your needs. It's about seeing text as a raw material that can be shaped, that can be molded to fit your purpose.
I like that visual.
And they also recommend a somewhat old-school technique, keeping an engineering daybook.
An engineering daybook. In this digital age, I'm intrigued.
It might seem a bit old-fashioned, but it's a powerful technique for capturing your ideas, for recording your decisions, for tracking your progress, and for reflecting on your experiences.
So it's like a conversation with your past self.
It is, a record of your thinking and how it's evolved over time.
It can be a great resource for learning from your mistakes, for identifying patterns in your work, for seeing how your skills have developed.
It's a simple but effective way to improve your self-awareness, to track your growth as a programmer.
Makes sense.
Now, let's move on to a concept that sounds a bit more formal. Design by contract.
Design by contract. Sounds official.
Or DBC, right. It's all about defining those clear agreements between different parts of your code.
Okay.
It's like having a contract, right?
Yeah.
That specifies what each piece of code is supposed to do and what conditions must be met for it to function correctly.
So it's not just about writing code that works. It's about writing code that's designed to work predictably.
Predictably.
And to fail gracefully, when things go wrong.
Exactly. It's about establishing a level of trust.
Yeah.
And predictability in your code.
Yeah.
Each function, each method, it has a contract that specifies its preconditions, its post-conditions, and its invariants.
Okay, remind me again. What are those? Preconditions, post-conditions, invariants.
So preconditions, they're the things that must be true before a function can be called. Post-conditions, they're the things that the function guarantees will be true after it completes.
I see.
And invariants, those are conditions that must always hold true for a particular object or module.
So it's about setting those clear expectations, those guarantees.
Exactly.
Yeah.
For how different parts of the system, how they should interact with each other.
It's about defining those boundaries, right? Making sure those boundaries are respected.
Precisely.
And how does this help, like, in practice?
Well, for one, it can help you catch errors early on. If a precondition is violated, right away, there's a problem in the calling code. It's like a built-in safety net
A safety net.
that alerts you to potential problems. So it forces you to think defensively
Yeah.
and to anticipate those potential problems and to put safeguards in place.
So it's about designing for failure.
Designing for failure, making sure that your code can handle those unexpected situations gracefully.
Makes sense.
And speaking of failing gracefully, they advocate for a somewhat controversial strategy: crashing early.
Crashing early.
I know, right? Isn't it better to try to recover from errors, keep the program running?
You'd think so, wouldn't you?
But sometimes crashing is the best option. It prevents your program from continuing in an undefined state, potentially corrupting data or causing even further damage.
So it's like hitting that emergency brake.
Yeah.
When you realize you're headed for disaster.
Exactly. It might be, a sudden stop, but it's better than careening out of control.
I see that.
They argue that trying to limp along in an undefined state can lead to those subtle bugs, those inconsistencies. They're much harder to track down. So it's better to fail fast, fail visibly, than to slowly decay into a mess.
I can see the logic there.
It's a bold approach.
Yeah.
But it makes sense. Sometimes, a clean break is the best way to ensure data integrity and to prevent further damage.
It's a tough call, but sometimes it's necessary.
And they highlight the importance of using assertions, those little checks we put in our code to make sure things are as we expect.
Those little checks, they can be lifesavers.
They are. Assertions are they're like those canary in the coal mine warnings. If an assertion fails, it means something is fundamentally wrong, and you need to address it immediately.
It's a way of enforcing those assumptions, right, that are crucial for the correct operation of your code.
Exactly. It's about building in those early warning systems that can prevent small problems from becoming major disasters.
Early detection is key.
Now, Chapter 20, it tackles the challenges of juggling the real world. Building applications that interact with external systems, handle those asynchronous operations, respond to events in a timely and predictable manner.
Juggling the real world sounds like a challenge.
It's a reality for most software developers.
Yeah.
We're not just writing code in a vacuum.
Right.
We're building systems that need to interact with users, with databases, with APIs, all sorts of external factors.
It's a messy world out there.
It is. And they start by emphasizing the importance of decoupling, which we touched upon earlier. It's about minimizing those dependencies between different parts of your code, making your system more flexible, more adaptable to change.
So it's like building a system with modular components that can be easily swapped, replaced, without affecting the rest of the system.
They warn against those train wrecks, those long chains of method calls that make it difficult to understand the flow of data, the flow of control.
Oh, yeah. Those can get out of hand quickly.
They do. It's about breaking down those complex interactions into smaller, more manageable pieces. It makes your code easier to read, easier to understand, and easier to maintain.
Much easier.
They also caution against the dangers of global data and of excessive inheritance, both of which, they can lead to tight coupling and fragile code.
Fragile code, nobody wants that.
Global data, it's like a ticking time bomb. It can create those hidden dependencies and make it really difficult to reason about the state of your program.
And excessive inheritance can create a tangled web of dependencies, right?
It can.
Making it difficult to make changes without those unintended consequences.
Exactly. They advocate for using techniques like events and reactive programming to build those more responsive and decoupled systems.
So events and reactive programming, they're powerful tools for managing those asynchronous interactions, creating systems that respond to events in a timely and predictable manner.
It's about designing systems that are more like choreographed dances, with different parts moving gracefully in sync, rather than like a tangled mess of spaghetti code.
I like that analogy, choreographed dances.
Now, this next concept is a bit mind-bending: transforming programming.
Transforming programming.
It's about shifting our thinking from a code-centric approach to a more data-centric one.
Data-centric.
It's about seeing programs as pipelines that transform inputs into outputs. So instead of focusing on classes and objects, we focus on the flow of data through the system.
So it's a different way of thinking about software design.
It is. It's a different way of thinking about it, but it can be very powerful, especially for tasks that involve processing and transforming data.
I could see that.
They introduce the concept of pipelines, which is about composing those transformations into a clear and readable sequence.
Like assembling a series of data processing steps, each with a specific purpose.
Exactly. It makes your code more modular and easier to understand.
And they emphasize that this data-centric approach, it can lead to more testable and reusable code.
It's a powerful paradigm shift that can change the way you approach software design. And this concept of data flow, it ties nicely into their discussion of concurrency and of breaking temporal coupling.
Okay. Concurrency, we've talked about that a bit.
Right. Concurrency is all about doing multiple things at the same time.
Yeah.
And temporal coupling, well, it's when your code imposes a specific order of operations. That's not truly required.
So unnecessary constraints.
Exactly. So it's about removing those unnecessary constraints and allowing things to happen in parallel when possible.
Which can really improve performance, especially these days.
It can significantly improve performance, especially in today's world of multi-core processors.
Makes sense.
They provide a great example. Fetching data from multiple web services. Instead of fetching them one after the other, you can fetch them concurrently, significantly reducing that overall execution time.
Oh, yeah. Like having multiple chefs working in the kitchen.
Exactly. Each chef can focus on their own task, and the meal gets prepared much faster.
I get it. Makes sense.
And they introduce different concurrency models, like actors, processes, and blackboards, each with its own strengths, its own weaknesses.
So it's about choosing the right tool for the job.
Right. Understanding the trade-offs between different approaches and designing your system to handle concurrency safely and effectively.
Safely and effectively.
Now, concurrency can be a powerful tool, but it also introduces new challenges, especially when dealing with shared state.
Shared state, always a potential problem area.
That's why they dedicate a whole section to the perils of shared state and the importance of using techniques like immutable data structures and message passing to avoid those common concurrency pitfalls.
Common pitfalls. We all fall into them sometimes.
We do. Shared state can lead to race conditions, to deadlocks, all sorts of nasty concurrency bugs that are notoriously difficult to debug.
Notoriously difficult. Those can be tricky.
It's like having multiple people trying to edit the same document at the same time.
Potentially overriding each other's changes.
It's a recipe for disaster.
It is. Chaos.
So by using those immutable data structures and by using message passing, you can avoid those situations, right? You can make your concurrent code much more reliable.
I see that. It makes sense.
So this has been a lot to take in.
It has. A lot to think about.
It's amazing how the Pragmatic Programmer, it covers such a wide range of topics, from like the philosophical to the very, very technical.
It's a dense book.
It's a testament to the depth and breadth of this book. And we're not done yet. Join us for the final part of our deep dive, where we'll explore the importance of teamwork, of agility, and of ethical considerations in software development.
Those are important topics. Looking forward to it. Ready to wrap up our Pragmatic Programmer journey?
I am. We've covered a lot, from those individual practices to the more technical stuff.
But software development, it's rarely a solo thing, right?
It's a team sport.
Exactly. And the authors, well, they dedicate several chapters to this, to the art of building and working in effective teams. They emphasize, fully functional teams.
Fully functional.
Yeah.
So what does that actually mean in practice?
Well, it means assembling teams that have all the skills, all the perspectives to build a complete product, not just developers, but testers, designers, product managers, even users.
Bringing everyone together.
Breaking down those silos, fostering a more collaborative, a more holistic approach.
It makes sense. Having everyone involved from the start.
Mm-hmm.
I mean, that could prevent those miscommunications, those misunderstandings. That happen when teams are working in isolation.
Happens all the time.
It does. And they also advocate for organizing teams around features or products rather than around technical disciplines.
So instead of having separate front-end, back-end database teams,
you have teams that are responsible for specific features, user stories. Promotes a shared sense of ownership, accountability.
It does.
And they highlight the importance of clear communication.
Of course, communication is key.
Within the team
Mm-hmm.
and with external stakeholders.
Absolutely. They suggest, using those tools, wikis, chat applications, even good old-fashioned whiteboards.
Keep everyone in sync.
It's about creating that shared understanding of the project's goals, the current status, the challenges. It's easy to get, caught up in our own little worlds, but communication is essential for for keeping everyone on the same page.
It really is. They also encourage teams to embrace automation, to free up developers to focus on those creative and challenging aspects of software development.
Makes sense. Let the machines handle the boring stuff.
Exactly. I've seen firsthand how automating those repetitive tasks like testing, deployment, it can significantly improve. It can improve productivity and morale. It frees up developers to focus on what they do best, writing code, solving problems.
Exactly. And they advocate for continuous integration.
Continuous integration, where those code changes are automatically built, tested, provides that rapid feedback, ensures that the code base remains stable.
It's like a safety net, right?
It is.
Catches those integration problems early on.
Prevents those situations where you spend hours, even days, trying to track down a bug. That could have been caught with a simple automated test.
Absolutely. Painful experience.
And they suggest extending that automation to deployment as well, using techniques like continuous delivery, continuous deployment.
So it's about automating that entire software development lifecycle, from code changes to production. Makes the process faster, more reliable, less prone to errors.
It's a powerful vision, I think, of a streamlined and efficient development process. And it aligns perfectly with their emphasis on agility.
Agility, yes. Being adaptable, responsive to change, focused on delivering value quickly.
They emphasize that agility is not a specific methodology, but rather a way of thinking, a set of principles. It's about embracing change, iterating rapidly, focusing on delivering working software frequently.
And they have that great quote, "Agile is not a noun. Agile is how you do things." It's not about those rigid rules. It's about being flexible, adaptable to the needs of the project, the team.
Empowering teams to make those decisions. To self-organize, to take ownership of the development process.
Creating an environment where teams can thrive.
Where they can experiment, where they can learn, where they can adapt quickly. And this brings us to the final chapter, Pride and Prejudice. What are the key takeaways here?
This chapter emphasizes, taking pride in your work, signing your name to your code, being accountable for its quality, seeing yourself as a craftsman, someone who takes pride in their craft, strives for excellence.
And they tie this concept of pride to those ethical considerations of software development.
It's not just about writing code that works. It's about writing code that's responsible, ethical, mindful of its impact on the world.
Software has real-world consequences.
It does. We have a responsibility to use our skills for good.
Absolutely.
Protecting users, considering the potential harm, asking those tough questions. Have I done my best to protect the user? Would I use this myself?
It's about building software that we can be proud of.
Software that benefits society, that improves people's lives.
So there you have it, folks. A deep dive into the wisdom of the Pragmatic Programmer. A book that's, it's just as relevant today as it was 20 years ago.
Absolutely. Timeless advice.
It's been an incredible journey exploring these timeless principles, these timeless practices.
It has.
And it's a book that I think every programmer, every developer should read and reread throughout their career.
A guide for not only writing better code, but for becoming a better developer.
It's a reminder that programming is, it's a craft, it's a profession, and it's an art, and that we have the power to make a positive difference.
With the software we create.
Until next time, happy coding.